Hello and welcome students. How is it everyone? I hope everybody is doing well. So this is lecture number 4 of this chapter chemical reaction and equation. So let's begin this lecture without wasting our time. Okay guys, so here we are. Here we will talk about displacement reactions. What we will study? We will study displacement reaction. Okay. So basically in this chapter, yet we have seen two types of chemical reaction. First one is combination reaction, and the second one is decomposition reaction. Decomposition reaction. But this is type number third, and the name of this type is displacement reaction. So, by the name also, we can understand that in this reaction, some kind of displacement will take place. So, the chemical reaction in which a more reactive element displaces a less reactive element from a compound is known as a displacement reaction. So, basically, who will displace whom? So, guys, the compound which is more reactive will displace the element from his compound which is less reactive. Now, the question is, how can we define the reactivity? So, I am writing here the list of the elements according to their reactivity. Okay, so this is K, and this is the symbol of potassium. This is the symbol of what? Potassium. And if I talk about reactivity, then this potassium is highly reactive. Highly reactive. Okay. Now, after this potassium, the second elements which comes on the second number, that is Na, and this Na is sodium. So let me write all these things clear. So first of all, let me erase this here and then write all the elements according to their reactivity. So this is sodium. It is also highly reactive metal, but potassium is the most reactive metal. After that sodium comes, and after sodium, calcium is the highly reactive metal. So this is what? Calcium. Then magnesium. This is magnesium. This is aluminium. Aluminium. And then zinc. Then Fe, that means iron. Then Pb, that means lead. Then hydrogen. Then copper. Then mercury. And then silver. Then gold. And then platinum. So here this platinum is less reactive. It is less reactive. So basically this is called reactivity series. What? Reactivity series. So if you are asked what is a reactivity series, so reactivity series is a series where we arrange the element according to their reactivity. So if you move up to down, then the reactivity will decrease. Okay, so this platinum is very less reactive, or you can say it is least reactive. On the other hand, the potassium is highly reactive, or you can say it is most reactive. So guys, the reactivity is like this. It is increasing from down to up, and again it is increasing down to up. So I hope guys you might understand what is a reactivity series. So what does reactivity mean? Reactivity means that how much will this element react to the other element. This potassium is highly reactive. It means it will react to the other elements very fast. Okay, if I talk about these elements which are on below or which are on bottom of this reactivity series, so they are less reactive. That's why they don't react with any other element very soon. Okay, so that's why this is Au, this Au is gold. So gold is found in its pure form. It doesn't react with anything very fast. Okay, so I hope guys you might have been able to understand why gold is so precious. Okay, now guys, let's talk about the full name of these elements. So this is zinc, this is iron, this is lead, this is already hydrogen, this is you already know copper, this is basically mercury. Okay, and it is the only metal which is found in liquid state. That is an important point. Now this is silver, Ag is silver, this is gold, and this is platinum. So I hope guys this reactivity series is understood by you. Now let's come to the point and let's talk about what is a displacement reaction. So the chemical reaction in which a more reactive element displaces a less reactive element from a compound is known as displacement reaction. So these reactions are also known as substitution reaction. Okay, if this reaction comes with this name substitution reaction, so you do not need to be confused because substitution reaction and displacement reaction are same. So guys, now a general displacement reaction can be represented by this A plus BC and then arrow sign, then AC plus B. So let's move ahead and let's talk about what does it mean. So basically guys, this is A plus BC is equals to AC plus B. So here in this reaction, this A is highly reactive, or you can say that this is more reactive than this element B. So that's why what will it do? It will replace this B from its compound and this AC will form. Okay, AC will form and this will displace B. So that's why, because it is displacing, this element A is displacing this element B from its compound. So that's why we will say that this is an example, or you can say this is a general term for displacement reaction. Okay, here two things are important, that more reactive element will displace less reactive element. Less reactive element. Okay guys, I hope you might have been able to understand this displacement reaction. Now we will talk about an example of displacement reaction. So the example is written in front of you on this slide. So what is happening in this example? Let me write it a little bit more clear to you. So guys, this is Fe. This is what? Fe. And Fe is iron and it is in solid form. So when this Fe reacts with copper sulfate, which is in solution, this is a solution of copper sulfate, and when you add Fe here, then what will happen? This Fe will displace this copper. And why will it displace this copper? Because Fe is more reactive than copper. More reactive than copper. This copper here is less reactive. So guys, now how do we know that Fe is more reactive? We know it because of this reactivity series. You have to memorize this reactivity series. So you can see that Fe is coming first, okay, and Cu is coming later in this series. So that's why Fe is more reactive than this copper. So it will displace this copper, and what we will get? We will get FeSO4 solution. For solution I write aqueous plus copper in its pure form because it displaces the copper. So this is an example of a displacement reaction. I hope guys this thing is clear to you. Now what will happen guys? Let's move here. So this copper sulfate has a blue solution. You can see basically the copper sulfate, the color of this copper sulfate is blue. Now what did we do? We basically put a iron nail inside this solution. So this is what? This is iron nail, means Fe. So we know that this Fe or iron is more reactive than copper. So it will displace copper, and because it displaces copper, so the color of this solution will become green. Okay, because in this solution FeSO4 will start to form. Why? Because this Fe will displace this copper from its sulfate. So it will become FeSO4, and this FeSO4 has green color. It is green in color. So that's why the solution of this, or you can say the color of this solution will change. It will become blue to green. And we know the reason that why it is turned green, because Fe displaces the copper. Okay guys, I hope you understand this logic. Now guys, when we started this chapter, then I told you that when a chemical reaction takes place, then what happens? You might have to see a change in color. So here in this reaction, you can see there is a change in color. So we can say, or we can confirm, that a chemical reaction is taking place. I hope guys this thing is clear to you. Now let's move on. Okay, so this example is also understood by you. So now let's move ahead to the next slide. Okay guys, so here we are. Guys, here we will talk about the fourth type of chemical reaction, and that is double displacement reaction. Okay, yet we have seen three types. First one is combination reaction, second one is decomposition reaction, third one was displacement reaction, and this is fourth type, double displacement reaction. So by the name also you can understand that here also there will be displacement between elements. Okay, so but this is a double displacement reaction. So in this type of reaction there is an exchange between ions between two reactants. So there is a change of ions between two reactants, then these type of reactions are known as double displacement reaction. The general term for this double displacement reaction is written here. AB plus CD is equals to AD plus CB. So guys, you can simply see that there is an exchange between A and C. They are displacing each other. A is taking place of C and C is taking place of A. So that's why this is a double displacement reaction. Now guys, you might be confused that what is an ion. Okay, what is an ion? So guys, let's suppose this is zinc. Okay, this is what? Zinc. So if this zinc loses two electrons, so because it donates two electrons, so there will be plus 2 charge on this zinc. Okay, so this is what? This is iron. This is iron. Okay, and let's suppose this is chlorine. Now if this chlorine accepts one electron, then it will become Cl minus. So this is also iron. Okay, so in the reactions where there is an exchange between ions or two reactants and new compounds are formed, then we will call those reaction double displacement reaction. So here we will talk about the example of double displacement reaction. So you can see when the solution of barium chloride reacts with the solution of sodium sulfate, white precipitate of barium sulfate is formed along with sodium chloride. So in this example you can see that here BaCl2 is written, and this is what? This is barium chloride. Barium chloride. Okay, and this Na2SO4 is what? It is sodium sulfate. It is what? Sodium sulfate. And because you can see here Aq is written, so it means it is the solution of sodium sulfate. Here also Aq is written, so it is the solution of barium chloride. And this BaSO4 is a precipitate. It is a precipitate and it is the chemical name of this barium sulfate. Barium sulfate. Okay. When this sulfate ion was with Na, means sodium, then we were calling that compound sodium sulfate. But now it is with barium, so that's why we are calling it barium sulfate. And this is what? This is NaCl. And NaCl is sodium, this is sodium and this is chloride. When this sodium combines with chlorine, it will call chloride, sodium chloride. And this is a very important compound, NaCl. This is what? This is our common salt. Common salt. This is used in our houses daily. This is our common salt. Okay, and if you are asked what is the chemical formula of common salt, then you will say NaCl, and you will call it sodium chloride, and its famous name is common salt. Now guys, you can see in this reaction that there is an exchange of elements. You can see this Ba takes place of this Na and become BaSO4, means barium sulfate, and this Na takes place of this Ba. So it will become NaCl. So that's why there is an exchange of ions. So we will call it a double displacement reaction. I hope guys this thing have been understood by you, and in this reaction you can also see that this BaCl2 was in a solution. This Na2SO4 means sodium sulfate was also in a solution. When we combine these two solutions, then this NaCl is in aqueous, but this barium sulfate is a precipitate. It is a precipitate. So this is also an example of precipitation reaction, which I will be telling you later. Okay. So guys, I hope this is completely understood by you. Now let's move ahead on the next slide. Okay guys, so here we are. Here we will talk about precipitation reaction, which I was talking about just before some time. So what is a precipitation reaction? Basically guys, you can understand all the reaction just by reading their name. In combination reaction, what was happening? Two reactants were combining and giving one single product. In decomposition reaction, what was happening? One single reactant was broken into the two or more products. Okay, so by the name we can understand decomposition means there is a decomposition of the reactant. Now in the third, or you can say on third number, we studied displacement reaction. So one element was displaced in that reaction. And what we had just seen, double displacement reaction. And what we had seen in double displacement reaction, that there is an exchange of ions, or you can say two elements were displaced, or they exchanged their positions. So that's why that was double displacement reaction. And here in this type of reaction, because there is a formation of precipitate, so that's why it is called precipitation reaction. So let's read this definition. The reaction in which precipitate is formed by the mixing of aqueous solution of two salts is called precipitation reaction. So if you mix two aqueous solutions and if a precipitate is formed, so those reaction will be known as precipitation reaction. And if I write example of this precipitation reaction, so it will be AgNO3, and I will take it in a solution. So you might be confused, sir, what is this AgNO3? Tell us its name. So basically this is silver. This Ag is what? Silver. And this NO3 is what? This is nitrate. Nitrate. When I was telling you decomposition reaction, then we studied there lead nitrate. So this is silver nitrate. So guys, when we mix this solution with the solution of NaCl, NaCl is what? This is our common salt. This is our common salt. So I'm taking also its solution, and the name of this NaCl is sodium chloride. Okay, and when these two reacts, so they will give AgCl, which is silver chloride, and this AgCl is in solid state. It is what? It is in solid state. So I can write it here, silver chloride, and this is also a precipitate. Okay, and you can also see that this is an example of a double displacement reaction, because this Ag has taken place of this sodium, and now this sodium will take place of this Ag, and it will become sodium nitrate, NaNO3. So this is what? This is sodium nitrate. Sodium nitrate. Okay. And I told you that when this NO3 was combined with Pb, means lead, it was lead nitrate. Then it combined with silver, it is become silver nitrate. When it combined with sodium, then what will be the name of this compound? Sodium nitrate. So it is as easy. And this is also a solution. Okay, this is also in aqueous state. So I hope guys this reaction is completely understood by you. Okay, what is a precipitation reaction? You can be asked this question. So what will you say? You will simply say that the reaction where precipitate is formed by the mixing of the aqueous solution of two salts is known as precipitation reaction. So now guys, after understanding this, let's move on and let's talk about the other reactions. So guys, in this slide, we will talk about neutralization reaction. Okay, so basically this reaction, you will completely understand this reaction when I teach you acid and bases. Acid and bases. So what is this acid and base? There is a whole chapter on this topic. So we will discuss this acid and base there. But for now on, you just need to understand that if there is a reaction between acid and base, then this reaction will known as neutralization reaction. Talk about the example. So let's suppose this is NaOH, okay, and it will known as sodium hydroxide, okay, and when this sodium hydroxide reacts with HCl, then it will give us an ACl, which is a salt, and it will also form water, H2O. This is water, and this is an ACl, means sodium chloride, and this is known as common salt. Okay, and this is what? This is HCl. It is hydrogen, because there is an hydrogen and there is in chlorine as well. So I will write hydrogen chloride. Let me write it, hydrogen chloride. Now guys, this HCl is basically an acid. This is an acid. And this NaOH is basically a base. This is a base. So there is a reaction between an acid and a base. And this NaCl is salt. So if there is a reaction between an acid and a base to form a salt and water, by an exchange of ions, then this reaction is known as neutralization reaction. So you can see there is an exchange of ions. So I told you what are ions. Let's suppose this is an A plus, this is an ion, and this is Cl minus, this is also an ion. So if these ions will combine, they will give NaCl like this. Okay, and this is basically H plus ion. When you break this HCl, it will give you H plus and Cl minus. So this is H plus ion, and here this NaOH will split in Na plus and OH minus. So they will combine and give you H2O. So you can see there is an exchange of ion. There is an exchange of ion, and a salt is formed and water is also formed. So this reaction is known as a neutralization reaction. Okay, so I will tell you later what is acid and base. Here you can just understand that acid have H plus ions. Okay, if you dissolve the acid in solution, then they will give H plus ions, and they are sour in taste. They are what? Sour in taste, like a lemon. When you taste a lemon, then the taste of a lemon is sour. So basically, there is an acid in the lemon. And on the other hand, there are bases. So bases are bitter in taste. Okay, bases are bitter in taste, like the baking soda or the caustic soda or the soap which we use are made of these bases. Okay, so this NaOH is an example of a base, and this HCl is an example of a acid. I hope guys this is understood by you. Now let's move ahead on the next slide. So guys, here we are, and on this slide we will talk about some examples. Okay, so first of all we will try to solve this example number first. So let me read this question. How is exothermic reaction is different from an endothermic reaction? So this is an easy one. Okay, let me write solution here. So we all know that what is the difference between an exothermic reaction and an endothermic reaction. So exothermic reactions are the reaction where heat is evolved. Heat is evolved. And endothermic reaction, endothermic reaction are just opposite of the exothermic reaction. Here heat is given. Heat is given. Okay. So these are different equation. These are opposite reactions, and this is the solution of this question number first. Now guys, let's talk about the second question. Okay, so let me write the solution of this second question. Find out the type of chemical reaction. Okay, so here some chemical reactions are given, and we have to find out what is the type of these reactions. So first of all, let's talk about this first reaction. So here lead nitrate is decomposed in three products: lead oxide, nitrogen dioxide, and oxygen. So because lead nitrate is decomposed, so that's why it is a type of what? Decomposition reaction. Decomposition reaction. I hope guys you get my point. Now guys, let's talk about the second option. And here it is given that this water molecule, or you can say this H2O, hydrogen dioxide is again decomposed in hydrogen and oxygen gases. So here it is again a type of decomposition reaction. Decomposition reaction. And if I ask you what type of decomposition it is, then you will say it is a electrolytic decomposition, because we break these water molecule by providing or by flowing electricity across it. So this is a type of electrolytic electrolytic decomposition. Okay, now guys, let's talk about this third reaction. So Fe is reacting with copper sulfate and it is formed, or you can say FeSO4 is formed. So here this Fa means iron is displacing this copper and taking its place. So that's why it is an example of displacement reaction, because here this element is displacing this copper because it is highly reactive. This is more reactive than copper. So that's why it is displacing copper from its compound. So that's why guys, this is an example of displacement reaction. Displacement reaction. Okay. So this is the answer of third. So I hope guys these examples are clear to you. Now let's move ahead on the next slide. So okay guys, now we are ending this session. Thank you so much and we will meet in the next lecture. So bye bye.